Hi, welcome to the third questions for Centripetal Force in circular motion. Okay, let us try this question together. A conical pendulum is formed by whirling a stone of mass 50 gram. Okay, so we have the mass here. Okay, we have the mass, but in gram, you will have to change to kilogram, the SI unit. At the end of a string of length 0.25 meter, this is the length, the stone completes 10 revolutions in 5 seconds. You can get revolution per second, RPS. Calculate the tensions in the string, the angle that the string makes to the vertical, means this angle theta, and the radius of the circle if the speed of rotation is halved. Okay, let's do one by one. We have the mass. We already have the mass. We have the length here. And here it says 10 revolutions in 5 seconds. So calculate tension, angle theta, and find the radius. Okay. So this is the information given. Mass, change to kilogram already. Meter, length. And the 10 revolution per second in 5 seconds, we can find frequency. Okay. You just take 10 revolutions divided by 5 seconds. So what do we get? We will get 10 divided by 5, get 2 revolutions per second. Okay? Or you also can write as 2 RPS. 2 RPS. 2 revolution per second. Now, okay, believe me, if you have frequency, it's better you straight away find the omega. Yeah, believe me. You can find omega once you have frequency. Omega is 2 pi f. Okay, 2 pi f. Okay, the actually frequency also can write as 2 per second. Yeah, the unit. Or also can write as 2 hertz. These are all the units. All right. So 2 pi f. So f is 2. Okay, you know this frequency means it make 2 rotations in 1 second. 2 rotation per second. 2 revolution per second. You make 2 turn. In 1 second, time, you can make 2 turn. Right? Okay, find omega. So you get 4 pi radian per second. That's the unit for omega. Radian per second. 4 pi radian per second. Now, we got the omega. Find the tension. Okay, whenever you want to try circular motion question, you must begin with drawing free body diagram. He say it is a conical pendulum. Conical pendulum. It looks like a cone. A cone. So it looks like a cone like this. Yeah, when you turn like in a cone, whirling the stone. So these are the stone. This is the stone. This is the string. Now at the left hand side. So draw free body diagram. Show all the forces. First, you must draw a point. Yeah, draw a point at the center. You must draw the point mass. Yeah, you must have a point mass at the center, and all the forces coming out from the point mass. Yeah, all the forces you must draw coming out from that one point, the point mass. So it has the string attached. So it is pulled by the string. So it has the tension along the string. It has the weight downward. Okay. And because the circle is at the right hand side, the center of the circle is at the right hand side of the object. So the centripetal acceleration is towards the center of circle. Okay. Centripetal acceleration always towards the center of circle. So centripetal acceleration AC is also to the right. Okay, towards the center of circle, to the right. You must show the AC. You must show the AC, must draw the AC because we want, later we will put the positive and negative sign for the forces. After that, you see the tension has angle theta. Okay, this is the angle theta the string mixed with the vertical. So when this is theta, this is also theta. Yeah, this is also theta because it's like alternate angle. Yeah, alternate angle. So when you see you have tension with angle, you must resolve first. Okay, always resolve all forces with angle to get the x component and y component. So here we have if we start with this one, adjacent to angle, adjacent to theta is t cos theta for y-axis. The x-axis is opposite to angle, so it is t sine theta. Okay, good. Now, follow acceleration positive, opposite acceleration negative. So what we can say is the t sine theta is positive. The t sine theta is positive because follow acceleration. And you see, in x component, it has the acceleration, means the resultant force is only at the x component. So t sine theta is the resultant force. Understand? T sine theta is the resultant force. Yeah, the resultant force. And this resultant force is the centripetal force. So T sine theta is the centripetal force which is required for the pendulum to move in a circle. It is the T sine theta that makes the pendulum to move in a circle. Okay, this T sine theta serves as the centripetal force for the circular motion to happen. Okay, now let's continue with doing our equation for x and y component. So as we have seen just now, the AC acceleration is at the x component. So that's why Fx equal to MAC. This one also equal to FC itself. So what forces we have in x component? We only has the T sine theta. And it is positive because follow acceleration. Okay, so write that down. Write that down. T sine theta equal to MAC. And T sine theta, MAC, just AC. This time, because we already have omega, so our AC, we substitute with R omega square. So our AC don't use V square over R, we use R omega square. Because we have omega. Understand? Okay, so now for on first, let's do the y component. So the y component, we have the t cos theta and mg. Okay, t cos theta and mg. Okay, so just we don't have acceleration in y component. So going up is positive, going down is negative. That's all. So t cos theta minus the mg equal to 0. That's it. Yeah. So what do we have? T cos theta is mg. Okay. So we have two equations. Equation 1, equation 2. So we must do simultaneous equation. Okay. So just take the first equation, the sine divided by cos. The sine divided by cos. So we take, because we want to use sine divided by cos to get tangent theta. That's why you use 1 divided by 2. We use 1 divided by 2. So t sine theta divided by t cos theta equal to the mr omega square divided by mg. Okay? Now we can cut off the commons, tension, the mass, the sine divided by cos, we get tangent. Okay, sine divided by cos, we get tangent. And here is left with r omega square over g. That's it. Okay, now we don't have the radius actually. You see that? We don't have the radius. We only have the length. So how? We only have the length. We don't have the radius of circle. You know, this is a circle. This is a circle. The circle has radius r. But this r is not equal to the length of the string. No, the length of the string is the hypotenuse. So we need to find the radius of circle first before we can proceed. You see the R here? So how? So you can see this is actually a right angle triangle, just like this one. I draw over here. Radius, if we want to find the radius of the circle, we need to use trigonometry. We have the length here, theta here. So how? Okay, R is opposite theta. So we can use what? We can use sine theta equal to opposite divided by hypotenuse. Sine theta is opposite divided by hypotenuse. R divided by L. That's it. So we got our R. Our R is L sine theta. All right. R is L sine theta. So just put inside. Oh, okay. Seems like okay, never mind. Tangent theta equal to R. R just now is L sine theta. R is L sine theta. Just put inside. L sine theta omega square over G. Oh, now we have tangent theta and sine theta. Oh, seems like we no need to make it tangent theta. We remain as sine theta. Then we can cut off. So change back the tangent theta into sine theta over cos theta equal to L sine theta the omega square over G. Then we can cut the sine theta. Then easy to solve the questions. So we no more sine theta. We only have cos theta there. So okay, let's continue. So cos theta. Okay. I mean go upward, sin cos theta go upward. So this one also interchange. Interchange, so it becomes G on top and then over L omega square. Okay, that's it. Okay. Now we have all the values. We have all the values. We have the what? We have the L. We have what? L. We have L. We have G. G value is 9.81. Yeah, it didn't specify. Omega, just now we got omega. Omega is 4 pi. Okay. So just just now the L is 0.25. So let's calculate. Let's put inside. Yeah. Our G value is 9.81 divided by our L is 0.25 meter. Our omega is 4 pi. Okay. So is it correct? 0.25 and 4 pi. 0.25 and 4 pi. Yes, that's correct. Now, so calculate, and we got our theta as 75 degree 75.61 degree. Yeah, that's our theta. That's our answer for part B. That's our answer for part B. We want to find part A. Part A asks for the tension. The theta, we got the theta. The string made vertical. Now the tension, how? Tension is just look back. Which equation can we use? Oh, we can use this one. Yeah, use the T cos theta equal to mg. The formula T cos theta equal to mg. So the equation 2, yeah, equation 2, T cos theta equal to mg. Our T is equal to mg divided by cos theta. So what is our mass? What is our mass? Our mass is 0.05 kilogram. SI unit, yeah? 0.05 kilogram multiplied by G is 9.81, the gravity. Our cos, our answer for theta is 75.61. 75.61, put inside. Okay, 75.61 degree. And our tension will be 1.97 Newton. Yeah, that's it. That's the answer, 1.97. Okay, that's our answer for this part A. Part A. Okay, that's our part A. Now, What's the last question? Part C. What is the radius of the circle if the speed of rotation is half? Oh, speed of rotation refer to the, can say this is as omega. This omega 2 is half. That means it's half of the first omega. Just now we got this is the omega 1, 4 pi. So now omega 2 should be 2 pi because it's halved already. Yeah, it's halved already. So want to find the radius of the circle. What happened to the radius? So, okay, we got our omega 2 is half omega 1. And because the speed of rotation is half. So just now our, just now our omega 1 is 4 pi. Yeah, our omega 1 is 4 pi. Just put inside 4 pi. So omega 2 is only 2 pi. Yeah, 2 pi radian per second. Okay, so we got our omega 2. So we want to find what happened to the radius. So see what equation we have omega first. What equation can we use? We can use the equation, yeah, we can use this one. Cos theta g L omega square. Right? That's our equation. Our equation, yeah, this equation we can use. We can use this equation. Yeah, this equation. You can use this equation. Now, cos g over L omega square. Okay, so write that down. Cos theta equal to g over L omega square. Yeah, is that correct? Yeah, correct. Now, we have the omega, we have the, what happened to radius? Okay, so let's find out. We have the omega, theta. What happened to the theta? What happened to the angle theta? L. Okay, oh, we need to find the theta. So let's find out the theta first. Okay, 9.81. So our L still remember the same. The length never changed. Length is 0.25 meter. So 0.25 times the omega. Omega now is, now we are using, now omega 2. This one also become theta 2. Yeah. All the others like G and L is always constant. Only the omega changes because the speed become half, isn't it? The speed become half, so the theta also changes. So we want to find a new value. Find a new value. So this is 2 pi as just now we calculate. So we got theta 2 equal to, our theta 2 now equal to 6.30 degree. This is our new theta 2. Now, once we got the theta 2, we can find what? We can find the radius. Our radius is equal to L sine theta. Okay? So, our radius equal to L sine theta. Find the new radius. This time is theta 2. The length never change. The radius change. The length never change. The radius of circle change. So, let's find out. Let's calculate. Yeah. Our L is always 0.25 meter, 0.25 sine the new angle now, which is 6.3 degree. Okay, 6.3 degree. And then we got the radius 2 is 0.0274 meter, which is equal to times 100. We get 2.74 centimeter. So our new radius is 2.74 centimeter. Is that correct? Radius of circle 2.74 centimeter. That's correct. That's our new radius. So you see, we need to use several equations before we can find the new radius. Alright, I hope you enjoy. Please subscribe and like my channel. Let's continue with the following question 4. See you, bye.